Welcome to myprojectbazaar.com. Let us see the demo of semi-supervised linear discriminant clustering. Clustering and dimensionality reduction simultaneously by connecting k-means and linear discriminant analysis. To find a feature space where the k-means can perform well in new space. To exploit the information brought by unlabeled examples. Analyze the influence of soft labels on classification performed by conducting experiments with different percentage of labeled examples. The findings shows that using soft labels can improve the performance particularly since different soft label estimation methods can be used in proposed method according to application requirements. Clustering is an unsupervised learning approach, so it does not require labeled data during course of clustering. The k-means is a typical clustering algorithm which aims at the minimization of average squared distance between objects and the cluster centers. The k-means generally use Euclidean distance as the distance metric, explaining why it can have good performance on dataset with compact supersphere distributions but tends to fail in data organized in more complex and unknown shapes. One of the problems with the high-dimensional dataset is that not all measured variables are important for understanding the underlying phenomena of interest. As a result, k-means does not generally perform well on high-dimensional datasets. Dimensionality reduction technique to improve k-means clustering performance. The goal is to find appropriate feature space where k-means can perform well in new space. Semi-supervised linear discriminant clustering which connects k-means and linear discriminant analysis to consider clustering and dimensionality reduction simultaneously. The k-means is an unsupervised learning method while LDA is supervised dimensionality reduction method. The goal of LDA is to find vector which can separate two or more classes of objects, but LDA requires sufficient labeled examples to obtain the projection vector. There are 5 modules present in our process. First of all, the high dimensional data and linear discriminant clustering and soft label via constrained PLACA and semi-supervised linear discriminant clustering. Finally, the constrained k-means. In high-dimensional data presence many mathematical challenges to machine learning tasks. One of the problem with high-dimensional data is note that all the measured variables concept of distance nearest neighbor are deteriorated in high-dimensional data due to course of dimensionality problem. Dimensionality reduction is tries to find the lower dimensional to learn distance metric without label information. The k-means is typical clustering algorithm which aims at the minimization of average object and cluster center to use dimensionality reduction technique to find an appropriate feature space. Clustering can perform well in new feature space compared with hard labeled examples. Soft labels allow each object belonging to all of clusters. In soft label via constrained PLSA, first it is an unsupervised learning method, so it does not require label data. Second, as general model, PLSA is based on mixture decomposition derived from latent class model where latent variable is discrete. Third, the latent variable introduced by PLSA infer more semantic information from observation. LDA can be used to reduce drastically the dimension of document representation in classification. Applying PCA first for dimensionality reduction is also method to make the within class scatter matrix non-singular. Reduce dimensionality first and then use soft LDA with soft labels obtained from constrained VLSA to find discriminant features. In constrained k-means, the constrained k-means to cluster data points in the reduced feature space conducts the experiments with constrained k-means in the original input space, experiments with constrained k-means in the original input space. Let us see our flow of our process. First of all, we are consider the data extraction. After that, we perform k-means algorithm and LDA. After that, we have to calculate the mean and distance. Finally, we are grouping the data. These are the discriminant analysis. Let us see the demo of our process. First of all, we have to run the home page. Create the database and the create table and import the file into the database. Data inserted successfully. Database is opened. Database connected. Set is connected. Then enter the number of clusters. For example, 4 cluster is formed. There is the 4 values. After that, this is the clustered values. We are using latent Dirichlet allocation and k-means algorithm for clustering the document. After that, we have selecting the class 1 and class 2 for discriminant analysis process. For example, selecting HAC as the class 1, we are selecting class 1 and class 2 are selected. We are performing the discriminant analysis. This is the latent Dirichlet allocation discriminant analysis process. This is the performance of LDA algorithm using label data. Thank you.